Hey guys, welcome back to another episode of Math Unlocked with your host, Mrs. Rhodes-Grierson. So today we're looking at number bases. I know that this is not new to you, but we want to dive into deep understanding of number bases so that we can look at conversion of number bases, right? So we all are familiar with the base 10 system, which is what we use. So let me not say we are familiar with base 10 because you might not have used the word base 10. You would have used the decimal system. Some of you may have heard of it as being the Denary number system. So we have three different names that we're calling it. Denary, base 10, and the decimal system. All of these are referring to the number system that you use every single day when you're adding, subtracting, multiplying, dividing. That's our system that we use. So from when you were younger, you would have been introduced to a place value chart, which is what I'm showing here. And you may have not been introduced to the aspect here, but I'm going to just let you know now. I'm going to tie it in for you. So you would have been used to seeing ones, tens, hundreds, thousands, and it continues. And then going in the opposite direction after the decimal point, you would have been used to seeing tenths, hundredths, and going in that direction. You know that the TH is added after the point. There's only one ones column on your place value chart. Now, where does this additional piece come in? Because the system that we use is a base 10 system, then the number base is having a base of 10 and a power. Now, how does that work? For the ones column, any number raised to the 0 power is 1. So we're starting from 0. So the ones column is actually coming from the base of 10 with a power of 0. That gives us our ones column. So any number that is within this column will attract 10 to the 0 power. Then the number within this column will attract 10 to the first power, and that's the 10 to the first power is 10, still 10. So that in the tens column, 10 to the second power, however, 10 times 10, because raising it to the second power means to multiply it by itself. 10 times 10, that's 100. 10 to the third power, multiplying 10 by itself 3 times, that will give us 1,000. And we'll keep going up in terms of the power, which is ascending in this way but descending in the other way. So many of you are familiar with how to work with a positive power, but let's look at the negative power and what it means. After your decimal point, every number after that is less than 1. A number less than 1 is a number that is a part of a whole, which means that it's a fraction. So this means that any number here can be represented as a fraction. What does 1 to the negative power, negative 10 to the negative power of 1 means? That is 1/10. And that's how we get the 10th position here. 10 to the power of negative 2 means that this is 1/100. So that's 1/100ths. So any number after the decimal point is fractional, and a decimal can be written as a fraction. So if you're asked for the value of a number within the decimal system or base 10 system or denary system, and using all those words, you get familiar with them. If you're asked for the value of a number, for example, if I ask you for the value of the 3 that is within this space, you check to see where is that 3. 3 is in the hundredths column. So what does that mean? It means I have 3 hundreds. So I could say that's 3 times 100. It gives me the value of the 3 based on the position of the 3. So I'm multiplying it by 100 to give the overall value that the 3 will obtain based on the position that it is in. So I'm going to take you over here now. What then would be the value of the 3 here, and why are they different? So the position that the number is in on the place value chart will determine the value of the number. So 3 is in the hundreds column, so it's 3 times 100, that gives me 300. But this 3 is in the 10th column. If it's in the tenths, let me just add an S to that because it could be more than 1. If it's in the tenths column, just as though I would have said that this is 3 times 100, this would have been 3 times 1/10. Because remember now I said that every number after the point is a fraction. A decimal represents a number that can be converted to a fraction depending on the value or where that number is. So 3 being in the tenths column means that it is 3 that is multiplying 1/10. What is the overall value of this now? If I should multiply 3 by 1/10, that means 3 times 3, 3 times 1 is 3, and 1 times 10 is 10. So that will give me a value of 3/10. Notice how this is 300s because it's in the hundreds column, but this is 3/10 because it is in the tenths column, but this is written as a fraction because it is less than 1. So this is how we know the value of a number and can represent the value of a number in the base 10 system. All right, people. So we've just explored the base 10 system, and we want to make a connection between the base 10 system and the base 2 system. Now, just as how I would have given you the words associated with base 2, so when you see them, you can just make the connection that it's the same base that we're referring to. Base 2 is also called the binary system, and we would have known the prefix bi that is associated with 2. So we know that when we say base 2, we're talking about the binary system. Now, we must also take note that a number system have a certain number of digits. So we would have been used to our base 10 system that has the digits from 0 to 9, and any number in the system, the base 10 system, would have been comprised of those digits. So if you're making a number, you have to use those numbers. With the base 2 system, however, it's a little different because we are only allowed these 2 digits, 0 and 1. So any base system, the base itself, if it says base 2, it has 2 digits. If it says base 3, it has 3 digits. Base 10, it has 10 digits. And all bases start from the digit 0. So base 2 will have 0 and 1. Now, I wanted to pay attention to what's happening here in terms of the place value. Notice that I started with the base being 2 because we said it's the base 2 system. And starting with a power of 0. From what I would have told you before about the binary one, any number raised to the 0 power is 1. So this would become my 1's column for base 2. Then I progress to the power of 1. So 2 to the power 1 is still 2. So this is now my 2 columns. My 2's column. So anything here will be multiplied by 2. This is now 2 to the second. That's my 4's because 2 times 2 is 4. So anything here we consider them groups of 4. These are groups of 2. These are groups of 1. These are groups of 8. These are groups of 16. And we could progress upwards, onwards. So I'm going to place a number on the place value chart. Notice that my number that I placed here are only 0s and 1 because that's the only thing allowed in the base 2 system. Now I want to find what's the value of the digits here. Is it different from base 10? Yes, it is. Let's, for example, look at this number right here. What's the value of that 1? Based on where the 1 is. The 1 is in the 4's column, which means this 1 is one group of 4. So I say 1 times 4. So the value of this one would have been 4. Now what we generally can do is that I can convert from one base to another. For example, I could tell you the full value of this number in base 10. Since if this is in the, let's look at them all. Let's look at all the numbers now. This is in the 16 column, so this is one group of 16. So I know I have 1 times 16 here. I have no group of 8s, so that's plus 0 times 8. Plus I have one group of 4s, so that's 1 4 times 4. Plus I have one group of 2s, so that's 1 times 2. Plus I have one group of 1s, so that's 1 times 1. I'm going to simplify this. 1 times 16 is 16.
plus this becomes 0 plus 4 plus 2 plus 1. Adding them all up, 16 plus 4 is 20. 20 plus 2 is 22, and plus 1, that's 23. This, however, is the value of the number in base 10, because what I would have done is to see the true value of each digit, add them all up to say what does it represent. The number, this number 10112, which is base 2, would have value 23 in base 10. So this is how I convert from base 2 to base 10. I want you to like and subscribe and come back. How do I convert from base 10 to base 2?